Hello, everybody. I don't know what time or day you're going to listen to this. We're recording this just on the Friday of 4th of July weekend. So I hope everybody has a safe and enjoyable weekend during this interesting time. It seems like a long time since Anna and I met in Omaha, way back in the BC time, which I guess it would help if I actually, nope, we're still recording, before COVID. So in any case, here we are. Part of my message today is to let people know a bit of what I've spoken about in a lot of other venues, and you can find talks on YouTube and other places on the web. But I want to make people aware of just how important forage agriculture is, not just in the United States, but globally. And also why I say that we need a ruminant revolution. If we're going to meet the goals of today's world, let alone tomorrow's. And to just kind of declare my interests, if you will, I'm an advocate for therapeutic carbohydrate reduction and ruminant animal agriculture. I've worked in forage agriculture for most of my adult life, and I work for a forage seed company, but I'm not representing that company today. But just, kind of let you know the perspective that I bring to the conversation. Oh, by the way, if you don't know, the taste test is not part of hay judging, but I think many of the people will understand that already. My background and training, as I've already mentioned, is in those sciences to do with healthy soils and healthy plants and healthy ruminants. And then I had personal experience starting in 2007 that led me to get very interested in human nutrition. And I'll talk about that in a little bit. I mentioned the challenges that we have coming at us. We frequently hear about the world of 2050 when it's projected we'll have 9 billion people that we'll need to feed, which would be somewhere north of 2 billion more than we currently have. That would require an increase in food production by doubling, essentially, accompanied with an increase in demand for animal protein of 2/3. And of course, we've got to do that essentially from the same land area. And there's several nuances to that that we could talk about, but just to give a sense of what we must achieve over the coming, 30 years. And I just want people to understand that we can't feed today's world without ruminant animal agriculture, let alone this world of 2050 that's coming at us. In order to meet these goals, we have to increase the efficiency and productivity of ruminant animal agriculture, not just in North America, but globally. And there's several things that we could talk about, but I get to stand in front of a lot of audiences that need to be informed or taught what is a ruminant and what role did they play in our past as a species, why they are essential today, and how they'll enable a truly sustainable future as opposed to some of the narrative visions that are presently discussed. So briefly, we've got these 134 species of ruminant animals today, and it's kind of remarkable that the majority of the animals that we've domesticated are herbivores, and the biggest part of that obviously are ruminants. These animals, we've been able to domesticate them in every biome that we've successfully colonized. or at least manage them in some way. But it's important to understand that these animals are not competitive with humans for food resources. In fact, they increase the food supply and they improve food quality of that supply. And they also provide some additional services. Ruminants are absolutely essential, and people talk about as if we could get rid of them, and there is no functional replacement for them. Primarily, they are critical for the conversion of structural and non-structural carbohydrates into fat. They convert plant protein, and notice that I put quotes around that, into highest quality animal protein. I'll talk a bit more about that shortly. They reduce the unstable polyunsaturated fatty acids into the more stable monounsaturated and stable saturated fatty acids through a process called biohydrogenation. They produce vitamin B12 and other vitamins. They increase the bioavailability of essential minerals over those same minerals provided from plant sources. They degrade the anti-quality plant components that we frequently suffer from in various plant source foods. They maintain the health of grassland ecosystems, which ought to be of concern to people in Nebraska, considering that you're basically in the major grassland area of North America. They recycle nutrients and build soil health. They provide services like draft and byproducts. They generate new wealth. All these are essential. This, simply put, we didn't evolve to eat meat. We evolved because we ate meat. All of the ruminants were in place something like 20 million years ago. The hominid ancestor was, what, 3 million years ago, something like that. And the modern Homo sapiens date back a couple 100,000 years. So it's pretty clear that the ruminants provided the resources that our ancestors exploited. And there's a whole lot of very interesting information that we could get into if we had the time. But the idea that our ancient ancestors were vegetarians is just a complete myth. And bringing it forward into today, the notion that raising livestock and consuming animal source food is fundamentally incompatible with sustainable development is flawed. This is a wonderful paper. I recommend it highly. Adeshogan's paper from last year, Animal Source Foods, Sustainability Problem or Malnutrition and Sustainability Solution. Perspective matters. And he's writing from the perspective of someone who came from Africa. He's now a faculty member in the United States, and they're engaged in research to improve livestock system efficiency in Africa, Southwest Asia, and other parts of the developing world. Or I guess the proper term is the low and middle income countries of the world. And here in the affluent or high income country of United States, it's easy to forget that it hasn't been that long since we were dependent on draft animals. And it's kind of entertaining to think about a draft moose or a saddle elk, although I think there's a safety issue with the elk there. I'm not sure I'd want to be that close to all those pointy things. But this was 100 years ago, but still today, 50% of the world's farmers are dependent on draft animals. And different parts of the world, the numbers are different, but without those livestock, we wouldn't have the food systems that we have today, let alone the ones we'd like to have in the future. And without livestock, there are some other impacts. We've got nearly 1 billion people in the world that don't have access to electricity. I think the figure that I saw recently was 45% of humanity consumes less electrical power in a year than the average North American refrigerator, which means nothing else that we're taking for granted, including access to technology like we're using to communicate and learn from today, is available to these people. They don't have it. And so if we're going to move forward into the world we'd like to see, we have to overcome those kinds of limitations. In this case, specifically 3 billion people in the world today rely on burning dirty biomass fuels, which includes dung. In this case, we have a woman with a tray of animal manure, and the pats you can see on the building behind her are drying so that they can burn that for fuel. Well, the European settlers moving across Nebraska once upon a time collected the dried pats so that they could burn them, but we've been allowed to progress beyond that. One thing to keep in mind is when you burn that fuel, you lose the nutritive value of it as a manure. And it turns out that the majority of fertilizer used in our cropping systems comes from manure. Even looking at Europe, where we're clearly looking at a high-income country, but more than 1/3 of the nitrogen inputs in their cropping systems are coming from manure. So if people are entertaining this narrative of eliminating livestock agriculture, where is the fertilizer going to come from to produce the crops that they think we can survive on alone? I think the figure is something like 60% of the world's fertilizer ends up coming from manure. So one of my messages is that ruminant animal agriculture is the truly sustainable agriculture. If it is not, then we don't have one. And that I want people to understand that when you improve your health, you are improving the world. It is completely reasonable for people to want to improve the world. But I don't think people recognize the impact that chronic disease, which is primarily metabolic disease, has from an environmental sense. And that if we could get more people to improve their health, that would enable perhaps the most practical means of improving the world. Today, non-communicable diseases are the biggest cause of death globally. Many people say that if we could stop feeding livestock, we'd have all this feed available to feed humans. And it's important for people to recognize that globally, the ruminant animal herd, less than 96%, or sorry, put it another way, less than 5% of the feed that goes into the global ruminant herd is human edible. Now, basically, that's the grains and the soy cakes at the top of this graph. And to get to less than 5% edible, it's important to recognize that 1/4 of those grains are not human edible. There's lots of reasons that a grain which might otherwise be edible is no longer considered human edible, grade issues and things like that. That's before we ever get to whether they should be eaten. But in this case, we're looking at 10% of the global cereal production going into the global ruminant herd. So if you were to get rid of this, it's not like you'd have this vast amount of feed available to convert into human food. And it's also important to recognize that when we feed those human edible proteins, in this case, to ruminants and convert them into meat and dairy, we increase the food value of those. And so we not only increase the protein supply, we improve its quality by feeding, by managing ruminant animals globally. And it's important to recognize that the alternatives, which would be produced under crop systems, have an environmental impact all their own. And one of their biggest impacts is soil degradation, either the loss of soil structure and or the loss of soil itself through erosion. And this idea that this is a resource that really isn't replaceable. Once we lose it, we lose it, and we can't eat the raw rock. We are entirely dependent on having healthy soils, and having ruminant animal agriculture systems allows us to use things like long-term rotations in perennial grasses, for example, which protect the soil from erosion and improve soil structure and quality. It's also important to have a more global view of the conversation. And frankly, we live in a world where a significant number of our brothers and sisters live where an egg a day would grow a better human brain. Something like a quarter of children 5 and under in the world today suffer from stunting. And this isn't just physical stature, this is cognitive development and brain development. And this stunting that occurs in childhood will last the rest of that person's life. And in fact, stunted mothers are more likely to have stunted children. Out of the 7 billion people in the world today, 2 billion suffer from micronutrient malnutrition. Basically, this is due to a lack of access, the lack of consumption of animal source food, period. So despite the narratives, there is such a thing as too little animal source food in the diet, and we see it. It's happening. I would suggest that the preponderance of evidence from all scientific disciplines strongly suggests that the most likely harm associated with meat consumption is from not consuming enough. I know that some people might argue, and I know that we need to have a fuller conversation, but we have evidence of the harm from too little. Where is the evidence of harm from too much? In any case, I'd like to move us all past the diet arguments, the diet wars, the us and them. I think people of goodwill ought to be able to agree on two things. One is that we need to focus on achieving adequate essential nutrition. And second, the importance of maintaining or restoring metabolic health. Now, I understand that there are going to be further conversations about both of those, but let's at least start there. And if we can't agree on those, then probably we shouldn't go any further, because we may very well not be dealing. We need to sort out some arguments before we go any further, I guess, is the easiest way to put that. So people should then, based on that information, choose accordingly based on their preferences, their situation, their responses. But I'd like to build bridges, and one of the bridges I think we desperately need to build is between the producers and the consumers. Because I think we're interested in the same things. I think, to quote Amanda Radke, that consumers and producers alike care about animal welfare, environmental stewardship, food safety, nutrition, taste. We could increase the list. I think it's likely that we'll have different perspectives informed by our different experiences. Can we please get together and start having conversations with each other? So my journey into this, the human health side of this, was fueled by my own personal experience. So starting in 2007, here's the Christmas picture where you set the camera up on the tripod and set the timer and run and get in the picture. And then when you look at the picture, you go, ooh, note the Hawaiian shirt, which is nice camouflage. And then 3 years later, I got to do it again. And this transformation was brought about by following a diet that was pretty much 180 degrees different than what we had been taught was the healthy diet by that time. And that was mostly following Protein Power Life Plan by Michael and Mary Dan Eads, as well as some other resources that were available. By that time, I had read Gary Taub's Good Calories, Bad Calories. And so the first thing that happened was I started to get mad because I felt like the industries that I'd been taught to support had been slandered and unfairly accused. And I also then wanted to help people understand this information. And so 2010, I began showing up at various events, and since that time, I've gotten to talk to a number of audiences, including this one, to just try to build bridges between my agricultural tribe and my therapeutic carbohydrate reduction tribe. But what do you know? You're just a forage agronomist. Well, one of the things I've learned is that there's a fundamental difference between policy and science. The two aren't the same. In fact, in many ways, they're polar opposites. Policy, once it's set, has a tremendous inertia that fights against change. And in the case of the diet, we understand now that there really wasn't sound science to support it when it was instituted, and over the years there hasn't been any that's come up that says, oh, we were right after all. And let me just continue a little bit. As a forage agronomist and as a ruminant nutritionist, I understand that crude protein is not true protein. In fact, crude protein is nothing more than the total nitrogen percent of a sample multiplied by a conversion factor, 6.25. This is because the assumptions are that all the nitrogen that was in that sample was in protein, and all that protein was 16% nitrogen. Well, there's a few problems with that assumption. Some proteins contain more or less than 16% nitrogen. Different foodstuffs contain varying amounts of non-protein nitrogen. That's not a problem when we're feeding ruminants, because as I mentioned earlier, one of its ecological functions is, thanks to the rumen microorganisms, they can capture non-protein nitrogen, form microbial protein out of it, which the host ruminant then digests. It essentially grows a crop of microbes and then harvests them. So there's no such thing as an essential amino acid in a ruminant's diet, while there is in ours. And the difference between crude protein and true protein is greater in plant source foods than in animal source foods. And the true protein that comes from animal source foods contains a higher proportion of what we have called nutritionally essential amino acids. So I know this as a ruminant nutritionist. What surprised me is how few human nutritionists understand that. And the result is that for almost half a century now, swine nutritionists have had a greater appreciation for essential amino acids in the diets that they formulate than human nutritionists have. And we don't digest protein. We absorb amino acids. And there traditionally has been this idea that there are these essential ones, non-essential. They began to talk about conditionally essential. Sometimes under certain conditions, some of these become essential. But it turns out that really all of that is a bit of a misnomer, because just because we can make some amino acids doesn't mean we can make enough if they're not in our diet, if they're completely removed from our diet. It'd be very hard to do that. But if you're not consuming sufficient protein, you could enter into this territory. Well, we're told that we overeat protein. Well, depends on when and where, and it depends on a couple other factors as well. If we look at different regions of the world, or we look at global average and look from 1969 to 2013, and I forget how many million more people we've had in that time. I want to say we've doubled. I could be wrong on that, but we've increased the number of humans, and we've increased the daily protein supply for those humans. That's a good thing. In some regions, we've dramatically increased the protein from animal source foods, which would be the bottom portion of each of these bars. But globally, more of humanity's protein supply is still coming from plant source foods than from animal source foods. And it's important to recognize that this is crude protein supply. So we just talked about why that's important. And there's this thing called the recommended daily allowance, and people look at that and say, oh, look, there's the evidence that we're over consuming protein. Well, not so fast. Because basically, the short version is the RDA should be considered a minimum, not a target. Okay, so then a moderate amount of protein intake, and this aligns with what you might learn from, for example, dietdoctor.com, is now represented within that blue shaded bar, that box that I've just drawn. Okay, so now that looks very different. Basically, only in the Americas or in Europe or in what's termed Oceania, so that would be New Zealand, Australia, for example, do we see protein consumption falling in that region? Certainly not globally. But that's a moderate protein, so note that we've changed the scale now. There's such a thing as an acceptable macronutrient distribution range of 10 to 35% of calories. Now this yellow box would represent that range for a 70 kilogram individual with a 2,000, I think it was 2,300 calories that I used for this calculation. Note that the lower range is actually above the RDA in this case. We could even draw a tolerable upper limit at 3.5 grams per kilogram body weight, which would even be above that. We shouldn't talk about protein intake in terms of percent of calories when we're feeding human beings. Human beings need an amount of high quality protein per day, and the amount of calories can fluctuate, but that amount of protein should not. And again, we're still looking at the plant source protein as if it's an equivalent on a gram for gram basis with the animal source protein. Oh, and by the way, there's a group called Eat Lancet. Yeah, get ready to hear from them again. We heard a lot from them about a year ago. They're back. This is their global diet that they would suggest that people eat only 1.5 ounces of meat per day. Yeah, I don't think so. Today, the reality is humanity, more of our global protein supply comes from cereals than from all animal source foods. And cereals are a really poor source of protein nutrition. Just they are. It's just a function of them. And yet, for the poorest 20% of the tropical population around the world, rice provides more protein per person than beans, meat, or milk. And it's low quality protein. And we'll talk about that here in just a bit. You can see clear evidence of the relationship between meat consumption and stunting, where the lower the meat consumption, the greater the rate of stunting. And where Eat Lancet would like us to be is down in the high stunting range, actually at a level of consumption equivalent to Haiti. Probably not, thank you. But it's not just in the low and middle income countries that this is an issue of protein consumption. Over 40% of Americans don't get enough. Most females over the age of 8 aren't getting enough. And this is even worse because this is based on RDA, number one. We've just seen that that's a target. It's a basement, not a target. And also this is considering plant and animal source protein as if they're equivalent, and they're not. And there's another little factor in here that I've recently stumbled across, and that's the variability of protein content, even in something like soybeans. So here's some values out of a sample set of almost 6,000 soybeans, and you can see that the crude protein value ranged from 29.5 to over 46.5%. With the average being 39% book value that's frequently presented. And that's what people use for creating labels or creating whatever. But clearly that's going to vary quite a bit. And we don't get that with the animal source foods. Animal source foods don't vary as anywhere near as much as the plant sources. And we can break it down into the individual amino acids. The yellow shaded ones are the ones that were considered essential. And you can see tremendous variability between those within that data set that was summarized in the previous slide. We could look at wheat. Remember that more of humanity's protein is supplied in cereals, and wheat is the highest crude protein cereal. 20% of humanity's protein supply comes from wheat. That's larger than any single animal source food. And wheat is a very poor quality protein source for feeding human beings. And as we get older, it gets marginally better, but it's still a low value protein source. And then when we process plant source foods, we can impact the digestibility of that amino acid composition. So in this case, we can see the dramatic reduction in the protein value of the cooked wheat cereal. It's interesting that when we look at animal source foods and we process them, we don't see that same reduction in nutritive value. And in some cases, we actually see something of an increase in its digestibility of the amino acids and the value of that in feeding human beings. So when we talk about processed animal source foods, when we talk about processed foods, we should not confuse animal source foods with plant source foods. That There's a fundamental difference that we need to keep in mind. And so far, I've only been talking about the value in terms of protein, but clearly all of these other nutrients come with, we don't just eat protein, we eat food. And that food comes with a number of nutrients. And in the case of animal source foods, they are nutrients that tend to be short in many people's diets. And if we would look at all these nutrients and fairly value their improved digestibility and nutritive value from the animal source versus the plant source, we could probably shift a lot of conversations. Just very briefly, I'm pretty certain we're not even talking about calories, right? In the case of sawdust, for example, it has a gross energy content of 4.4 kcal per gram on a 100% dry matter basis. So that 4.4, does that sound familiar? Kind of like how many calories are in a gram of carbohydrate or protein versus fat, right? We have that 4 versus 9. But the question is how much, what in animal nutrition, we're used to saying metabolizable energy, not gross energy. So how much of that is metabolizable? So in the case of ruminant nutrition, even though the gross energy content of both alfalfa hay and wheat straw are similar, we understand that there's a dramatic difference in metabolizable energy content between the two. I'm not certain, but what we're not even talking about the caloric content in human food stuffs correctly. And in any case, the difference between gross energy and metabolizable energy is much lower in animal source food than is going to be in plant source food. So if we're just looking at calories on a gross energy calorie basis, we're going to be getting far more metabolizable energy out of animal source food than we're getting from plant source food. Yet how are we accounting for energy intake in food feeding studies, et cetera, et cetera? So this is something else for us to look at a little bit. So basically, when it comes to the consumption of animal source food, there is such a thing as too little. I'm asking the question, is there really such a thing as too much? What's the evidence upon which people base their belief that there is? More familiar perhaps with the papers that came out just recently last year in the Annals of Internal Medicine. My interpretation of these basically says if there's an upper limit, it's not at current levels of consumption. People want to look at environmental issues, and so very briefly, just to touch on a few of these, it's important for people to recognize that ruminant animals are not alchemists. They're not creating carbon or nitrogen out of nothing. They're cycling it. They're part of a natural cycle that's going to take place. It's also important to make sure that we're talking about, we're talking in correct units and correct data concerning the anthropogenic greenhouse gases that come from animal agriculture. If you look at EPA values, we're looking at something like 9% of all anthropogenic greenhouse gas emissions in the United States come from agriculture, 9%. Now, that's not all from animal agriculture. Animal agriculture represents less than half of that 4% of the total US. And that's not all from beef. That's something like 2% comes from beef in the United States. So compare that to transportation, electricity, industry, commercial, residential. And if you look globally, that figure for livestock agriculture is like 14.5%. And that's not all from beef. So make sure that people are using the information appropriately. And even if we were to get rid of all animal agriculture in the United States, its impact on anthropogenic greenhouse gas reduction in the US, 2.6% of total, globally less than 0.4%. But it would come at the cost of unbalancing our food ecosystem and I would say exacerbation, the authors said creation of essential dietary nutrient deficiencies. But remember, we're not properly crediting the value, the nutritional value of the animal source food when we do these sorts of models. And when we do, we find that as it says, the production of protein containing animal foods would retain a much lower environmental impact than that previously estimated, lying approximately within the range of that of most foods of vegetal origin. But let's take it a step further. Let's look at the environmental impact of metabolic disease. We don't do that typically. And here's some figures that basically say that if the average type 2 diabetic in America could eliminate their medication use, they'd reduce their carbon footprint 29% more than if they switched from a meat heavy to a vegan diet. If there were only some way that a type 2 diabetic could eliminate their medication use, if there were only some way, what might it be? Oh, might look a lot like, for example, the VERTA effort and study. In this case, they're looking at data from, what was this? 1 year improvement, reduction of almost, well, over 50% plus or minus. In 1 year, they've just recently published 3-year data that shows this continued medication-free remission of type 2 diabetes. So we have a demonstration of a lifestyle dietary approach frequently utilizing more animal source food than the traditionally recommended healthy diet. And that has an environmental impact that we need to place on the scale against the environmental impact of raising the animal source food. And we haven't really done those models and studies yet. And I hope that I can help people do that. So getting a little snarky, both professions wear white coat, which produces more greenhouse gases. Well, if we were just to look at the beef industry alone, that's 2%. If we look at the US healthcare system, that's 10%. Maybe another way to look at it, and I'm indebted to Sean Baker, who put this up first on Twitter, but both professions wear white coats, which is better for your health. It might be time for us to relearn in human husbandry what we've known in animal husbandry for quite some time, and that is animal husbandry begins with proper animal nutrition. So a quick review: humans must consume other organisms. We can't photosynthesize, we can't eat raw rock. Animal products are superior sources of nutrition in the human diet. Ruminant animal agriculture offers unique ecological advantages over other forms of food production. There can be no sustainable agriculture without ruminants. Ruminants do not compete with human beings for resources. Ruminants increase the quality and quantity of humanity's food supply by improving the protein quality, by reducing the polyunsaturated fatty acids to forms that are not harmful. They increase the mineral bioavailability over the plant source foods, even those that are human edible, and they provide essential nutrients unavailable from plant source foods. Modern humans exist because of ruminants. Modern societies depend upon them, and they will be essential to the future of humanity. And the estimates of ruminant animal agriculture's environmental impacts are typically overstated, oversimplified, and frequently misleading. It's important for me to mention sometime along here that I'm not a human medical doctor. I'm not that kind of doctor, so I'm not giving medical advice, but I'm more than happy to help people find medical doctors, medical information. I'm happy to help people find research information to help them make informed decisions about their own health. And I would like to just pose the question to my agricultural tribe: what would be the impacts of more consumers coming to understand that red meat is in fact a health food, not a health hazard? And it's important for us to recognize that a tipping point is not 51%. Tipping point might be 18%. We could get enough people to understand this, then we would see a rapid transformation in the rest of society. So you can find me at various locations. I'm sure that these links will be posted somewhere, but you can find me on YouTube, you can find me on Twitter and Instagram, find me on Facebook, or you can email me at peter.ballerstedt@gmail.com. So with that, I'm done, and I promised 20 minutes, and I'm absolutely certain I've taken far more time than that, but I couldn't cut it down any further. So with that, we'll just call it good.